you all the participants for this wonderful faculty development program, Quantum Technology, which is a series of programs happening. So we are in QT02, and today we are about to have a look about QBraid, Universe, QSIM, and Quasim. All these tools are helpful to create quantum circuits. Not only creating quantum circuits, we are able to execute it, we are able to simulate it, we can able to run on actual quantum computer. Okay, so I will start from yesterday's session. So what we did yesterday, we went to Composer. So I'll share Composer link. So if you don't have account, if you don't have credential, don't no worry. You can do all simulation without having account also. So if you are comfortable with your credit card, you can create account over here. Good afternoon to all. So check your chat box. I already shared a link for this IBM Quantum Cloud. So if you don't have account, no worries. You can do all your experiments. So go to view, go to panel, enable all views. So it will appear in this way. So for each and every one, it will appear in this way. You can resize however you want. You can use in this way. Okay. So we'll start from yesterday's session. So yesterday we tried to create two qubit system. So try to rearrange your qubits. So click Q2, select bin button. So click C4, select minus button. Click C3, select minus button. So you can increase your number of qubits. You can increase your number of classical bits by adding plus, or you can decrease by selecting bin for quantum, by selecting minus for classical. So you can resize all this window, whatever you want, however you want. Okay. So left side you can see, you can have all these quantum gates and classical gates. So what you can do, you can resize collapse. So in this way, click this button, expand catalog, so it will expand. So this is the general default view, but you can make it this a view as a list. Click this button and you can view all these gate in listed way. Okay. So try to have experience by clicking all these options. So it will be helpful for you. All right. So yesterday what we did, we had a Hadamard gate followed by control NOT, and we had instructed one NOT gate, and we had two measurement gates. So this kind of circuit we created. Okay. So if we create this circuit, automatically you will get coding over here. So here you need to check right side, you can check this window. So click Qiskit. So equivalent Python code will be generated over here. So what you can do, you can copy this code. And you can go to your Google Colab and you can paste your generated code from the circuit diagram. Okay. So what I do, I try to share this code with you. So these are the necessary libraries you need to install before running your code. So check your chat box. I share this code. You can copy and paste in Notepad, or you can directly paste in your Google Colab if you are working side by side. So yesterday we did a little mistake. not a major one. We need to restart the session. So whenever if you install any packages, we need to restart the session. So that is the issue we faced yesterday. Okay. So copy paste the first command, try to install the QuizKit. So it will get package from the server. Okay. So the next command is you need to run, you need to install QuizKit IBM runtime. So run this. So I already installed all these packages. That is why it is saying satisfied. So next, if you want to display in LaTeX mode or LaTeX format, if you go for publication, this will be helpful. So try to install PyLaTeX package. Then next one is visualization. So yesterday we missed this package. So try to install the visualization. Then finally run your code. And this will generate output in this way. So what we did in Composer, we used the graphical user interface to create these gates to construct this whole circuit. We can do in coding also. Okay, so this is one version of the coding. So what I do, I try to minimize this code. So I try to remove these two lines. I'll make little zoom. So instead of giving quantum register, classical register variable, directly we can give parameter value in this way. So 2, 2 means 2 quantum circuit, 2 classical circuit. So this is very simple for you if you want to follow. So this will generate the same code, same output. Okay. If you don't mention any argument over here, so MPL, so if you delete this, if you run, it will just display in ASCII format. So note down these changes. So it will be helpful. So if you want to generate like a printed format, this will be helpful. But if you want to use multicolor, this will be useful. So all of you able to execute this code in your Google Colab? If so, you can put message in chat box. Okay, are you able to get the output? Good. So if you find any problem, what you do? So go to runtime. Okay, restart session. Again run the code. Definitely you'll get output. So this is most easiest way to run in Google Colab. Everybody having Google Colab, so you can do all these coding part. Okay, good. Then we can go for QBride. So this is very interesting tool. I'll share in the chat box. So go to this link. So try to create a login using your Gmail account. Again, one-stop solution Gmail. So once you created your account, you will have default workspace. Okay, if you are participating in IBM summer school, they will create a separate login for you. So for me, there will be little modification, right? So click default workspace after created your login. So click next. So initially for all user, they will give 4 GB RAM allocated for you, for each and every one of you, right? Then you can click launch lab. So they are giving different kind of setup. So always pick the first one, free 2 version CPU 4 GB RAM. Click launch lab. So once you created account in this cube, they will give exactly like Google Colab. So they will create a Jupyter notebook kind of interface. So when compared to Google Colab, this is so easy because you can change multiple version of Qiskit. Okay, you can execute the older version of code where you need to struggle a lot. Okay, so in this environment, they make it very easy for you. So try to click right side environment manager. So try to click environment manager. So try to click add. Try to click add. Okay, then you can click any packages, not only for IBM. So you can install Qiskit, you can install Pennyline, Google, Amazon bracket. Okay, so multiple options are there. So it supports multiple vendors, Microsoft, IonQ. Okay, so NVIDIA, right? Everything is there. Intel. So very good, excellent platform if you want to run multiple kind of quantum circuits and platform. Okay, so try to click Qiskit. Try to click Qiskit. You can change all these versions. So always I recommend latest version, Qiskit version 2.2.1. Okay, so click here. You can install whatever you want, whenever you want. So you can install the older version also. Suppose if you have code in older version, you can execute. So I will repeat once again. I know it is very quick for some audience. Okay, so try to click. So I try to create account in Cube. I already shared link in the chat box. Once again, I will share. If you joined late, please go to this link. Okay, try to create uh, uh, account using your Gmail. Okay, if you want to integrate your IBM, you need to put your API ID. So try to install the latest version. Okay, so once you created, you can take, go to file, go to new, click notebook. So if you want to work on notebook, you can use notebook. So they already installed some kernel, Python 3, Qiskit version 2.0.2. So likewise, whatever you install, you can select the kernel version. And you can directly paste whatever the code you generated over here. Then you can execute by Shift Enter. Okay, what we did, we copied from here. The same code we need to paste. Are you able to do? I will share this code, previous code. Okay, finally, in Excel, what you can do, you can able to visualize your circuit. So once you use Cube, you will like this. So wait for some time. It will take some time to load. Yeah, wait for some time. After creation account, it will automatically load. you will get this environment. So go to file, go to new, select notebook. So if you are not able to do parallelly, wait for some time. After this class, you can rewatch this video, then you can do. So this is about cube, right? Okay. So here, what you can do, you can select environment, you can add n number of Qiskit platforms. So you can use penny lane. So whatever we're going to cover tomorrow, we need to select packages from here. Yeah, no issue. Zero credit means no issue. I'm also getting zero credit. No need of Qiskit library because you already imported package from here. Okay, you need to install your environment. So that is why, that is what I told. If you are not able to do now, wait for some time. After this session, watch this video, then redo the same experiment. So it is very easy for each and every one of you. So at least in Google Colab, you need to troubleshoot. In Cube, no need to troubleshoot. My screen is not visible for you. So just re-login. Just re-login. So that is what I told. If you are not able to follow, wait for some time. After this session, you rewatch this video, then follow this. So very, very easy. Go for Cube. Go for Cube. Okay, create login. Do sign up using your Gmail. Once you do, it will ask which version you want. So select the first version by default. Okay. So this is extract tool I am talking about, which is not today's topic. So if you are feeling somewhat very hard to install all these packages, it will do for you. So that is why I introduced this tool. So people from other background, okay, non-computer science and IT, they will feel difficult to solve these error issues. I'll share this Python notebook. Don't worry, you can upload in your Cube, right? I'll tell Cube, right? Once you have login, you can upload your notebooks. So this is how you'll get. Okay, default workspace, select next. Okay, select version 2. I already running the system. Okay, I'll stop this. Sometimes it will take time, okay, to load this environment. So be patient. So if you have slow internet, it will take some time. Once lab is loaded, it will re-forward to this Jupyter notebook kind of environment. So it will take some time for first time. So be patient. Okay. So once you log in, you need to add environment. So this is important. So click add environment, select Qiskit. Okay. In Qiskit, you can find so many versions. So select the latest version. So this is what I recommended. So once you created, what you can do, once you install, what you can do, go to file, go to new, select notebook. Okay. So we will go for today's topic. Today's topic is about Universe. So Universe is a tool created by CDAC. So it is a Indian tool. So whatever we discussed, Qiskit, QBraid, all these tools are foreign tool. Okay, not developed in India. Okay, but most of the contributors are from India. for especially QuizKit. So if you are looking at QuizKit workforce, so first place take place in US. So after US, India contributed most of the code part. Okay, we can have so much of pride to create this QuizKit tool. It is a open source. Okay, but Universe is developed by CDAC. So it is a Indian tool. So if you want to support Indian tool, always use Universe. So I'll share this link with you. I'll share this link with you. So error we will discuss. Don't worry about these errors. I'll share a executed notebook in your repository, coding repository. You can run. So all of you go to this website. Check your chat box. All of you go to this website. Okay. So try to register. If you don't have account, click this register button. So give your details. Okay. If you request, they will take one day time. Okay. After verification, they will give access for you. So whatever the organization you belongs to, why you want to use the tool, you can mention all these things. The details are recorded over there. So if any quantum related program conducted by CDAC, they will intimate you through your mail ID. So this is very good platform. Okay. So whatever CDAC announces, everything come for your mail related to quantum. Okay. So promote this tool among your student community, ask them to register, ask them to get access. So in future, Indian government going to create any quantum computer, they will give access through this universe. Okay. So maybe Amaravati quantum system, you can access through universe in future. So once you got credential, you can log in. So you'll get environment in this way. So which is almost similar to QuizKit. They inspired from QuizKit and they develop most of the coding part from QuizKit. So this is the link. So if you know QuizKit, you can use all these quantum tools. That is the benefit. Okay, that is the benefit and advantage we have. If you learn one tool, that is more than enough. One language, that is more than enough. Okay, so this is similar to QuizKit. You can see the quantum bit Q0, Q1, Q2, C0, C1, C2. But what is the basic difference? Here you can see individual qubit and individual classical bit. So try to compare the same environment, just compare. So here you can see Q0, Q1 followed by C2. C2 means we have two classical register. But in Quniverse, you can see individually. So you can see little modifications here and there, right? So same way you can click Q0, Q2 and you can able to delete this. So go to file, go to new. You can create according to your requirement. Okay, click manage. Then you can modify how many number of quantum bits you need, how many number of classical bits you need. So here what you do, select 2. So here select 2. Okay, save. Now you got only 2 quantum bits, 2 classical bits. So whatever we did over here, we are doing the same thing. Okay, so Hadamard gate, NOT gate, followed by control NOT, followed by 2 measurements. So if you already registered, you can work. If you are not able to get access, wait for 1 day. So maybe by tomorrow or day after tomorrow, they will give access for you. So Hadamard gate, followed by NOT gate. followed by control NOT gate, and we did 2 measurements, right? So here you can see exactly 2 measurements. So little difference is there. Here you can see in the same line, everything is measured, but here you can see individually. So this will give some in-depth insight about which qubit is measured against which classical bit. Okay. So you can expand this, you can expand this, you can minimize. Then you can select the coding part over here, Qiskit. So this is the code generated over here. So click here, click Qiskit, Quasi Qiskit. Python code is get generated. Yes. So this is somewhat old version. Okay. This is somewhat old version of code, which is not latest updated to Qiskit 2.2. So be aware about this. Okay. Not only Qiskit, you can convert the same code for Google. Okay. This is the SIRC tool created by Google. I'll share this link with you. SIRC, which is developed by Google. Again, if you know Python, you can work on SIRC also. Similar to IBM Qiskit, only packages, syntax are a little bit different. You can easily understand any quantum packages. Okay. So not only Google, you can select CUDA-Q, so which is created by NVIDIA. Okay. I'll share this link, CUDA-Q. So if you already know NVIDIA platform, you can use this tool, easy for you. Then what you can do, you can convert into multiple versions, right? Qiskit editable, where you can edit your code. Okay, so this is about universe. So universe could integrate your quantum simulation code with quantum hardware. So right now they implemented with server and the GPU. I will tell you how to integrate all this stuff. So this is a unified platform. So to inculcate ingenious development. Okay. So it is a redefining way of developers, researchers, enterprises engage with quantum technology. Suppose if you are working on this tool, if you are able to crack certification from CDAC, you able to do wonderful things. So CDAC introduced certification. So I will share that link with you. So before I forget, I will share that link with you. I'm not able to share file. Okay. So I will show link for you. So this is the brochure released by CDAC just 1 day or 2 day before. So they are giving developer certification. So you need to register for this. You need to pay 1,000 rupees. So I recommend each and every one of you go and register by yourself. Okay, they will give 5 problem statements. You need to solve using Qiskit Universe platform. Okay. If it is possible, I will share that link with you. While sending this material, I will share this PDF also. So what is the advantage of clearing this certification? If there is any internship in CDAC, okay, if we are students or if you are able to clear the certification, they will consider you. Okay. So if there is any vacancy in CDAC, they will consider the person who already cleared the certification. So that is very good advantage for each and every one of us. Okay. So Kiniverse architecture is mapped in this way. So you can do quantum intermediate representation circuit. The circuit is converted into multiple platform supported versions. So not only Qiskit, you can use Google, you can use Kudaku. So number of architecture are keep on added. Okay. And what is the beauty about this CDAC tool? There are preloaded quantum algorithm. Suppose if you want to implement any quantum algorithm, if you don't know how to code, they already coded minimum circuits. So it will reduce your quantum development time. Okay, I will show how to do all this stuff. So wait for some time. So you can do optimization and you can do hardware constraints. You can pick your hardware where to execute your quantum code. So whether if you want to execute in CPU or GPU or vector based or FPGA based or real quantum system. Right now you cannot use real quantum system. Only through IBM account you can use from CDAC tool. In future they will give access to ingenious quantum computer. Okay. So everything is integrated through HPC Slurm. So again, this is a tool. This image belongs to CDAC. So they have this PDF publicly available. You can go through it. Is that clear? Okay, thank you. And in future, if any quantum systems developed across any institute in India, they able to integrate. Okay. Suppose if IIT Madras is able to create some quantum computer using photonics, they can integrate. Okay, or any uh, NMR, okay, NMR computer is available in either Pune, they able to interact and communicate. So in future, this tool will give more freedom for you. So right now, what we are doing, we try to access only the hardware provided by IBM, but in future, you can access any quantum computer or any quantum system which is developed in India across any institute. So that is very beautiful vision about CDAC tool. Okay. So what you can do, you can unify all these interface. Either you can go for graphical base if you don't know much more about coding part, or if you are very familiar with coding, you can do coding, you can execute. Okay. Then you can optimize the algorithm libraries and you can do hybrid computing. And they are giving comprehensive learning ecosystem. I'll show you how to look for documentation. Now it is in very preliminary level. It will take some time. In Qiskit, you have very beautiful documentation because they developed tool before 10 years. So this tool only developed before 1 or 2 years. So it is very much in baby steps. So wait for some time. Yes, we can do. Uh, yes, we can do. So why Q-universes matter? Because you can reduce development time because they have predefined libraries, preloaded libraries. Okay. So it will provide enhanced debugging and testing. It will show so much of errors, right? And how to fix it. They will try to improve the system. And you can convert your code into any platform. If you develop for Qiskit, you can convert the same code in Google also. Okay. So it is, I think it is not open source. I'm not sure about that, but Qiskit is purely open source. Maybe they will open this universe tool in future. Right now, I don't know exactly. Sorry about that. So that's all about universe introduction. Now we can see how to go for so here you can see compute resources. So click compute resources. You can have all these kind of simulators. Okay, simulators are ample amount of simulators. And I already registered using IBM Qiskit API ID. That is why I am able to access real quantum system. For you, it may not be available. Okay. So once you registered, you are able to access your real IBM quantum system through Quniverse. If you click QPU, these are the available QPU for my account because I'm using past 2 years. Right. Then you can go for the third option, algorithms. So this is very beautiful part of about this tool. I'll share this link with you. So for an example, if you want to create a algorithm based upon Dodge algorithm, okay. So here you can load your circuit. You can select your options. Okay, click load your circuit. So automatically it will preload from the library. Okay, preload from the library. You can have that particular algorithmic circuit. So this is very easy for you if you want to run, if you want to execute. Okay, if you click run, it will ask where to run. If you want to execute the circuit in normal CPU, you can run. Or if you want to execute in GPU, you can run. Okay, if you want to execute in vector based, which is not enabled now, in future they will enable GPU. They can enable IBM or Superstar hardware. Okay. So you can select HPC, high performance computing. You can run on Param Utkarsh, which is a supercomputer built by CEDA. And you can select your simulator background. Okay. So normally you can have multiple simulator backends. So each and simulator will execute your circuit in little differently, right? So try to work on all this stuff. Have some time. You'll get familiar. So what I did, I selected the circuit. Okay, I selected a HPC UACC cluster and Quasim simulator. So if you are not able to access Universe, wait for some time. They will verify your account. Within 1 or 2 days, they will grant access for you. So once you submitted your job, you can view your job status. Okay, I submitted 982, 9822, so which is about Deutsch algorithm. Okay, which resource I selected, which background I selected, everything came. So once it is completed, you'll get access. So I always try to mention the maximum time within 5 minutes. If you are able to access, very good. Okay, now they increase that speed to grant access. So it will take some time. Refresh. So I will show the completed job. So this is one completed job. Okay, you can see result over here. Suppose if you want to create any conference paper or journal paper, so this is very easy for you to take your output and put in your paper. Okay, so have this look. If you got error, it will show what is the error. Okay, all this detail you can get. We'll go back and check whether my code is executed or not. Still running. So refresh. Completed. So no error, executed the given circuit. Okay, so this is the given circuit. If you click transpiled code, according to your hardware, it will change your circuit. So now I didn't change any hardware, just simulation I did. So I got the same circuit. Okay, but in case of the previous one, you can see the transpiled code. So here you can see, cannot see the difference. Okay. So come to IBM. If you have IBM account, come to IBM. If you have IBM account, so click here, click compute resource. I'll share this link with you. So these are the resources available for me. Okay. You can select according to your choice. So this is how you can select your computers. So you can have lot of algorithms. This is Deutsch-Joshua algorithm. Okay, Bazrani. Then Simon algorithm, Grover's. Grover's is used for unsorted database. If you want to search anything in the given database, you can use Grover's algorithm, which is the algorithm proposed by an Indian. Okay, Low Grover is the scientist name. He created this algorithm, which is one of the foremost algorithm in quantum. And he can do quantum teleportation. For some algorithm, you need to give some input. For an example, Deutsch Joshua, you need to select how many number of qubits you want to generate. Okay, so I check 2 qubits. I select different types of functions. Okay, f of x equal to 0. I click load circuit. So this tool will generate circuit for me. I no need to worry about coding part. Okay, so most of the time I'll got. Okay. So until 10 qubits you can generate code. Until 10 qubits you can generate code. More than 10 qubits, you need to write. So each and every tool has some limitation. So before using your tool, you need to know what are the strengths, what are the limitation available in the tool. So this tool is not supported for 127 qubits because it only creates 10 qubits. So this is not a easy question to answer, very difficult. So try to learn step by step. To understand the algorithm nature, it will take 6 months or 1 year. Okay. So once again, I will tell how to study quantum computing. So go to learning tab from IBM. So I'll share this link with you. Yeah, whatever you are asking questions, all these questions have separate topic. So I can see. Okay. So click view all courses over here. Day by day, they are improving this course repository. So whatever available yesterday, today they changed everything. They gave number sequence. They mentioned number of hours. But this number of hours exactly will not match according to you. So each and every user will take extra time. Okay. So they are generously putting 5 hours, but most of the time it will take 20 hours also. Okay. So start with basics of quantum information. So whatever you are asking, how to map our problem, how to pick our algorithm, I try to answer in this demo. very hard question to answer. So every one of you, please go through this course slowly, very slowly. So you can see four lessons. Click single system introduction. So it will load YouTube video. So this course is taught by Professor John Waters. He is teaching quantum computing in Canada for past 35 years. Okay. So if you are watching this video, it will go for 1 hour or 1.5 hours. You cannot watch this video in a single stretch. So if you don't know any single term, you need to pause that video. Then you need to go for Google or ChatGPT. You need to do some basic research. Then you need to come back to video. So you need to pause your video. Then you need to rewatch. So this is the only way to understand quantum, to study quantum. So if you are in hurry, you cannot understand quantum. Okay, even if you are learning slowly, it will take so much of time. Okay, because it requires so much of prerequisite. That is the difficulty about quantum. So you need to understand linear algebra, you need to understand probability statistics, you need to understand all these basic stuff. Little bit of quantum mechanics, little bit of physics and coding part. Okay, for each and every one of us, learning all this stuff, refreshing all this stuff will take some time. Okay. So what you can do, you can download slides over here. You can click this link, you can download and you can take printout. So what I suggest for each and every one of you, try to go by printed material. Okay, you won't get tired. So if you keep on watching video, you'll get tired. Okay, so watch video, parallelly read from slides in physical paper. That is what I told. Linear algebra, probability statistics, okay, basics of quantum mechanics. If you don't know, they will cover. If you don't know, you need to cover. So multiple options. So they given lot of text. You can go by text. Suppose if you don't know any of this terminology, do basic research, then come back. So there is no single answer for this according to the user level. Linear algebra is very, very necessary. Without linear algebra, we cannot learn quantum. We cannot learn quantum. So, right? So once you completed this course, what you can do, you can take exam. So exam is free of cost. So they will ask 20 questions. Out of 20, you need to clear 16. So this is the first course you need to do. Then you can gauge your understanding about quantum, or how much easy for you or how much difficult for you. For each and every person, it will vary. So once you completed first course, what you can do, you can go for second course, quantum algorithm. So somebody has algorithm, right? So which algorithm to choose for which kind of problem? First, you need to understand what are the capacity for quantum computing and how quantum algorithms are working. So you need to know the basic principles. So the second course will help you. So for first course, for each and every one of you, second course, if you want to do something about quantum algorithm, you can go for course 2. Okay. So if you are from mathematics, you can go for course 3 and course 4. Okay. So this will give error correction. So once you completed that, then you can gradually go for quantum machine learning. Okay. Variational algorithm design, then quantum chemistry. So according to your domain, according to your interest, you can select your course. Okay. It is up to you. It is up to you. So once you completed all this stuff, if you want to scale up your application level, you can go for utility scale. So even though they mentioned 5 hours, definitely it will take 20 or 25 hours according to the participant level, right? So once you completed, you can go for quantum business foundation if you are from management side, or you can go for quantum cryptography if you're interested in cryptography. Okay, these are the courses, what you can do. If you want to teach quantum in your classroom, okay, you can use this link. I'll share this link. So these modules will help you to showcase some interactive tools in your class. So students will like and you will enjoy. So use these tools. So each and every modules contains perfect documentation along with the video, okay, along with the coding. So this is a simple experiment what we discussed yesterday about a coin flip, tossing a coin. Okay. So we are running for 1,000 times, and what is the output we got? We can able to check in our cube, right? So where we have cube, right? We created over here. So this is nothing to do with quantum. This is for basic understanding about coin flip. So even a Python tool can execute this code. I'll share this code in the chat box. You can run if you want. So again, if you don't know Python, it is very difficult. Try to get help from computer science or IT faculty in your institute. So learning Python will take 1 or 2 months. So this is how you can approach. So this is how you can approach according to your domain. Okay. Then you can see what are the documentation available in Universe. Now it contains very little repository. So if they are open for all participants, open source, we can generate documentation. So here they gave user guide. So if you don't know what to do, how to do, they gave user guide. So which is very, very minimal when compared to Quizzkit because it is in infant state. Okay. So you can get all these details like webinar if they are conducting. Deviation will be very high if you go for higher number of qubits. For lesser number of qubits, you cannot have that much of difference. So simulation will support until 30 or 35 qubits. Beyond that, you cannot do quantum simulation. Definitely result will vary. So what happens in simulator, we are adding a noise module, okay, which is created by us. But if you run in real quantum system, the noise are very real. So the noise will make a huge difference in your result. So simulation will help until a preliminary level. So beyond 30 qubits, it won't help. For understanding, this is more than enough. For understanding all these tools until 30 qubit system simulation, that is more than enough. Okay, we covered universe. Next, we need to cover about QSIM. So this is one of the tool developed by CDAC. So you can put in chat box if you have doubt. Somebody lowered your hand. Yeah, everything is available. Go and watch quantum algorithm. They mentioned this topic. Max cut they mentioned. So this is a tool developed by CDAC and IISc Bangalore and IIT Kharagpur. We can run until 127 or 133. That is why I showed how to access your compute resource. So go to this page and you can see how many qubits you can access, 127 or 133. See, we don't know how to use 127 or 133. our problem should be that much big enough, that much big enough. So initially, if you're learning, so handling 50 qubits is so much difficult for you. So it will take minimum 6 months time to understand how to go for 100 qubits. Don't worry about number of qubit access. Okay. To understand how to utilize 100 qubit, this course will help you start exploring practical applications. Okay, I will recommend that course. Quantum computing in practice, you can see 100 plus qubits. So I can zoom for your reference. So if you want to develop a use case, if you want to use more than 100 plus, you need to cover these, at least these two courses. It will take ample amount of time. If you complete these two, then only aim for 100 plus. Then you can look for utility skill beyond 100 plus. Whether I share that? Oh, yes, yes. So try to increase complexity little by little, right? First, try to understand 1 qubit system, then go for 2, then go for 3. Gradually increase the complexity. Are you able to access this QSIM? So click this link. Click this link. So try to register. Try to register. So I already registered. I try to log in. So this is the previous tool. So compared to the CDAC tool, both are CDAC, but Universe tool. Okay, this is the earlier tool. So where you can see the same stuff. You can build your circuit. Okay, not by graphical way, by coding way. Okay, you can code here. You can upload your code over here. Using they are not providing course. Universe is more than enough. I'll check and tell you. I'll check and tell you. You can upload your code over here and you can execute. Use Universe, and you should know this tool also. I think a lot of changes happened in this tool. Okay. Maybe you can use Universe. And this is one simulator developed by IAC Bengaluru. Okay. I'll share this paper with you. So this is one kind of simulator tool created for IBM as well as QSIM. They contributed. They contributed to IBM QSIM. You can open notebook over here. So same way what we did in Google Colab, we can open Jupyter Notebook over here. So taking some time. After some time, we will check. Okay. So in my login, I got these examples. I don't know whether you got the same kind of environment. So they gave 10 algorithms, okay, which is very, very less when compared to Universe. Okay. Fine. Okay, no issue, you can use Universe in that case if it is taking longer time. Fine. The next topic is about open quizzing. I'll share this link with you. So this open quizzing is imperative programming languages, which is a neutral language. You can assume in this way. So whatever you are developing in QuizKit, if you want to convert in Google version, so this language will act like intermediate, neutral language. Okay. So open quizzing is like open source. So whatever the quantum platform, if you are working, you can convert one quantum language platform into another quantum language platform code. So this makes interoperability. So as a faculty, as a researchers, we need to execute multiple tools. Then we need to compare multiple results. Then only we can give a validated comparison, right? So for that, open quizzing will help you. So this is the detail. So this is language neutral. Okay. So multiple parties are involved. Take an example of Zurich. So Zurich, you have uh, this university, ETH Zurich. This is the very good university in quantum. If you want to rank the first university in this quantum, I recommend ETH Zurich. So go and check this university. Okay. So I recommend one YouTube video about ETH Zurich. ETH Zurich. They are providing masters in quantum. So this is very good video about promotion about the university. Just watch this video, you will like it. So this university stands 10th rank in QS. Okay. So only one university from Europe stands first 10 rank. Okay. So this university contains 18 quantum related laboratories. So which is very big setup in entire globe. So you cannot see these kind of laboratory even in US. Okay. So people who are admitted in this MTech program, only 18 per year. So from India, one or two they admitted so far. So when compared to China, nearly 6 students are get admitted each and every year, but only one from India. Okay. So those students from India, they completed masters from IIT Madras or IIT Bombay. They completed BTech in engineering physics. Okay. So imagine the competition. Okay. The students should complete engineering physics and they should have recommendation letter from quantum related professor or scientist from India. The scientist also from top list. So this is the criteria. Only one or two students they will get admitted from India for each and every year, which is very, very low. Okay. So So I'll share this link. Please have this glance. They have 18 quantum related laboratory and no country able to create that kind of environment because they have CERN. CERN is very near to this ETH Zurich University. So recommend your student, okay, to pursue masters in ETH Zurich. So recommend them to join in IIT Madras or IIT Bombay, where they have masters in quantum. Maybe in future, our students get admitted in ETH Zurich. Okay, so this is about ETH Zurich. Why I came over here? Because to introduce open quizzing. So this is a collaborative effort. Okay. So ETH Zurich is involved, IBM Quantum is involved, and Zapata Computing is involved, and University of Oxford and AWS. So multiple parties and vendors are involved in this tool. Okay. So you can see this online masters, no use. So if you want to work quantum, you need to work in lab. So that is basic criteria. Otherwise, those students will not get placed in quantum industry. So what is the difficulty about quantum? Getting hardware resources. So in India, we have very, very less hardware resources. So that is why it is very difficult, very difficult. So doing an online course will give a advantage, but will not get in R&D. Okay, so go to Composer. Go to Composer. So where we have Composer. So go to Composer. If you design any circuit, okay, so automatically you can get this open quizzing code. So this code will act like intermediate version. So whenever if you do any quantum virtual labs, what I told, all these tools are virtual. So this Composer is virtual, Universe is virtual, all are virtual simulators. So don't confuse with virtual machine. In classical, we'll use virtual machine. Here simulator, that's all. Actually, simulation is a virtual one. We are not doing exact hardware execution. I hope you are able to get the idea. Okay. Yes, sir. Thank you. So this is my circuit. I have Hadamat. I have control knot. Only 2 qubits, 2 classical bits. Okay. So what I do, I'll select Qiskit over here. I'll select open quizzing. So whenever you do any quantum experiment, you keep your source code of whatever the quantum version you are using. Also, you keep this open quizzing. Okay. Suppose in future, if this tool is not available, you can execute the same code in different platform. So this is my suggestion for you, right? Then what you do, you can select setup and run. You can select setup and run, and you can select your hardware. You can select your hardware. Okay, select your hardware, run on your circuit. So what is this showing? We need to do measurement. So here there is an important note you can take. In simulation, you no need to do measurement. Okay, only in quantum execution, you need to do measurement. So without measurement, there is no meaning of quantum execution. So if you are doing any quantum experiment, at the end, you need to measure. So without measurement, you cannot get classical result. So that is why it is showing error. So do measurement, then execute, setup and run. So select your quantum system, run. So once you submitted, each and every job have details like job ID. Okay. So what is your instance? What is your name? From where you registered? Okay. So how many times you need to do? Everything will come. So look at this. My code is executed immediately. I am so lucky today. Okay. Sometimes it will take time, or sometimes it will take 1 day or 2 days. So depends upon the credentials. So depends upon the level, depends upon the waiting period. It will take so much of time. Suppose if you are running, it will take 1 day. So bear with that. Okay. So whatever I gave circuit, it is entanglement. So entanglement, what will get? 0, 0, 1, 1. Okay. But in my result, I also got 0, 1, 1, 0. Okay. So 0, 0, 1, 1 is only the correct answer. 0, 1, 1, 0 is wrong answer. But in quantum experiment, you'll get all kind of outputs. So that is beauty about quantum execution. If you do simulation, ideal simulation simulator, you won't get these two values. So this is the difference between simulation and real execution. Okay. So if you look at this graph, the maximum amount of result happen only for correct answer. So the minimum number of output happen for wrong output. Okay. By comparing this, you able to know which one is correct output, which one is wrong output. So wrong output happen during noise. So whatever you do in quantum, noise will impact in quantum system. Okay. These noise are responsible for this wrong answers. So intrinsically, we have randomness. So apart from randomness, noise also reason for wrong outputs. So this is what I discussed. Whatever you have circuit, that is converted into basic circuit in this way. So we selected one quantum hardware, right? So according to the quantum hardware, your gates are get changed. So this is called transpilation. So remember our circuit. So what we gave? We gave this circuit. But how it is executed in quantum hardware, entirely different. This circuit is converted into this set of gates. So you can imagine these are universal gates. These are universal gates. So universal gates for selected quantum hardware. Selected quantum hardware. So this circuit will change according to the hardware. So this is like machine dependent. Okay, what you can say, this is quantum hardware dependent. So in classical computer also, right? Like transpilation here, yes, transpilation, exactly. Not compilation, this is transpilation. So note this word, transpilation. So in quantum, we will use transpilation instead of compilation. So compilation for classical, okay. So this is for classical, this is for quantum. Yes, you can put your message doubts over here. So this is the open quasim version. This is the Qiskit version, right? So you can have log files. So if any error happen, all these detail you will get. Yes, professor, you can put, if you're raising hand, you can put your question in chat box. Right. So go to OpenQuasim. Go to OpenQuasim. Try to understand how they are developing. Suppose if you are teaching compiler, theory of computation, okay, OpenQuasim will help you to understand how to do quantum compilation or transpilation. Okay, so you'll get design goals, and you'll have scope, what they supposed to do. So they publish some paper. Suppose if you are involving with assembly level language, compiler, okay, theory of computation, this will help you to create the similar thing for quantum also. Already I shared link, you can take, you can check with your Presentation, sir. I gave slide. You can communicate with me. I gave all my communication details. So coordinator will share after 1 or 2 days. Right? So this is about open classroom. So if you have enough time, what I can do, I can give Quiskit foundations. Okay. I try to cover little bit elaborated version. How to use board. Okay, fine. So what you do, normally you will act like a end user. So you are creating some circuit, some coding. Okay. So all this coding will be converted to cloud service. So you are accessing cloud service. So your simulator, everything existing in this cloud service. Suppose if you want to access the real quantum system, what happens? Your code is again transmitted to server. Okay. In server, it will put in some queue. Suppose if you are accessing real quantum hardware, your code is stored in this server. Okay. Your code is get put in the queue. Your job is put in the queue. Okay. After some time, if your real quantum system is free, okay, then they will allocate time for your code. It will go. All your code is converted to pulse sequence. So these are microwave pulses. So whatever your code is there, it is converted into quantum signals. Okay. So these signals will be executed using quantum processor. Okay. So all your real quantum computation will happen in this quantum processor. Your results are sent back via pulses, signals. Okay. So all these signals again converted into result. So your result are transferred to your cloud server. Okay. From your cloud server, you're able to access your result. Okay. If you do simulation, this lies in this for the first circle. Okay. This is about your simulation. Okay. So what is the use of Qiskit? Qiskit is a open source framework, especially developed for quantum simulation and execution. So with the help of Qiskit SKD, you can create quantum circuit, you can use quantum operator, and you can execute quantum processing unit. So everything you can do within a single framework. Okay. Now they released Qiskit 2.0. This is the latest version where they introduced C programming language based API. Okay, using Python. So in future, they will use less Python, more C native code. So C is much more faster when compared to Python. So that is why they are focusing on C as well as in the case of Rust. Okay, in future, the C programming will take up as well as Rust will take up. So this is one important point you need to note. You can note this point over here. So C standalone using C, no Python runtime dependency because they need to execute in faster way. Okay, they try to convert all this code base from C API, C native. Then they are using Rust. So these two programming languages are notified and they are executing 2 times faster and 20 times faster transpilation when compared to Python. Okay, so all these instructions are given. how to install QuizKit, how to access hardware. If you want to access hardware, you can get from this link. So I will share this slide after this session. So don't worry about this. So it will take some time. It will take some deep steep curve. Okay. So this is how QuizKit is divided. So whatever you are doing, everything is uploaded to HPC server. Okay. So you have quantum computer, you have high performance classical computer. So whatever the supercomputer right now they try to integrate with quantum computer and supercomputer. Okay. So everything is managed by QuizKit cloud service. So this is their layer. Okay. So whatever you do, everything is abstracted services. So all these QuizKit service available in abstracted services. So GUI environment you're using, coding you're using, everything is from first layer. Okay. So this is integrated to development tools like QuizKit SKD, SDK, add-ons, transpiler. So everything will come below this abstraction layer. So this will convert all your code. Okay. So this will integrate all your code to HPC. So in future, it will happen, right? So all your code is converted according to the quantum computer hardware. So according to the hardware, each and every code will have different versions, different pulses. So this is how you get quantum computation. So once you do computation, all your results will come back to previous top layers. So level by level. Suppose if you are not able to access quantum computer, you can access CPU, otherwise you can access GPU, or you can access artificial intelligence unit. Okay. So not each and every time you need to execute in real quantum system. So this is very expensive. So normally IBM will charge nearly 9,000 rupees per single minute. Okay. How much time they are giving? 10 minutes. So this is very big opportunity for us. So most of the time we no need to use actual quantum computer without knowing how to use it. So 99% of the time simulation is more than enough. Okay, try to understand the simulation. Once you got confidence, once you need exactly 100 qubit problem, then go for real quantum system. So this is my suggestion. For understanding for 6 months to 1 year, simulator is more than enough for you, right? So if 100 people are using quantum platform, around the 100, 74% of the user base are using QuizKit. Okay, so nearly 74%. So how many projects are available? Nearly 5,000 projects are available in QuizKit repository. So that is why IBM QuizKit is so unique. They have so much of code repository and projects. If people more using a tool, more projects will get generated from the tool. Okay. So this tool contains so much of credibility. So if you are doing some publication, they will ask which tool you are executing. If this tool is reliable, your execution is also reliable, your experiment is also reliable. Okay, they try to compare with other tools. They try to compare with other tools. Okay, like Penny Lane, Microsoft tool, Google. So apart from that, so QuizKit occupies topmost cadre, 74%, right? And execution also very faster way. So already discussed with this stuff. Okay. So in Amravati, they going to deploy dedicated system. So in future, you can access this dedicated system through IBM also, through QUniverse also. So that is why I recommend each and every one of you to register QUniverse. So learn QUniverse parallelly according to the QuizKit. So this is the answer somebody asked before. Suppose if you have problem, okay, you need to identify your problem. You need to decide whether your problem need quantum computer or not. So this is very tricky question. So most of the time you never require quantum computer. If your problem not involved with complexity, if your problem not involved with randomness, if your problem not involved with combination and permutation, no need to go for quantum. Okay, you can solve with using HPC itself or AML model itself. Suppose if your problem involved with randomness, random guess, random computing, okay, then you can consider quantum. In that situation also, whether you have real complexity, okay, you have so much of combination, permutation, then you can consider for quantum. Okay, this is how you need to map your problem. Once you identify your problem, you can convert into quantum circuit by choosing specific operators. So once you create a quantum circuit, you cannot execute straight away. You need to optimize your quantum circuit in multiple times, multiple ways. So you need to select your quantum hardware. Okay. So whatever IBM is providing, it is only superconducting quantum hardware. Okay. For some problems, superconducting is not sufficient. Quantum annealing will help you. Okay. Photonic computer will help you. Or nuclear magnetic resonance will help you. So according to your problem, you need to select your execution, not only for supercomputing. Okay. So once you fixed your hardware, that hardware is suitable for your problem, then you can execute. Once you execute it, after execution, you'll get a result and you need to process your result. Sometimes you need to do post process also, right? So this is the simple workflow. So for this, QuizKit provides so many tools. Okay. So just now we come over graphical based and code based. So all these QuizKit libraries are available. So try to explore this QuizKit library set. So once you do, you need to do transpilation. So whatever I said, everything you can see over here. Okay. Then you need to execute. Then you will get quantum results in the form of quantum information. Okay. You can execute in multiple ways. You can have some add-ons. So according to the problem, according to the execution, you can add up your add-ons, right? So this will differ from problem to problem. Sometimes you can use tensor network. Sometimes you can use supervised learning. So according to your problem, you can select your add-ons. So this will help you to execute quantum chemistry type of problem. Okay. So out of 1 year of research, you can reduce up to 2.5 months. In future, this time will keep on reduced. So whatever you do laboratory experiments for 5 years, in future you can get the same result within 2 or 3 months. So this is beauty about quantum. Okay. So quantum will inspire you. Uh, you will get hooked to quantum once you involved with quantum computing. Okay. So whatever I discussed, they gave in a layout diagram. So take some time, go one by one. So if you complete first 2 courses, you can understand most of these points. So this is about BISCIT introduction and architecture. I'll share all this material with you. So don't worry about this material. We have plenty of materials. So learning will take some time. So that's all about today's class. If you have any question, you can ask me. We have plenty of time, 20 minutes. Thank you all for patiently listening. I will introduce one more tool, IonQ. So whatever I discussed, quantum annealing. So this computer is somewhat different. So this IonQ quantum systems you can access through Qiskit, or you can access through AWS. So multiple ways you can access quantum computer. So go and have look about IonQ. And AWS has some tool called Bracket. So they are giving 1 hour free simulation per month. You can use this. Very good opportunity. But they will request credit card. So be aware about the credit card information. So read the sentence, terms, conditions. Okay. Then try to create the account. Sometimes if you forget to stop your process, they will charge you. So that is one backfire in these options. Okay, you can ask any questions if you have. NMR, this is very good question. Very good question. I try to answer one by one. So Iser Pune, Iser Pune, NMR. If you Google, you can see this. You can see this facility. Whether my screen is visible to you, share. Yes, I will tell. I will tell. I'm looking for that group where you can find the group. Research group website. Okay, this is. So this is their facility. They are using nuclear magnetic resonance. I visited before 2 years. They have 30 qubit system, which is entirely different. So, all these cylinder will act like mega magnets, okay, which is 10,000 times powerful when compared to Earth's magnetic field. Okay, they have some samples. They have some samples. They'll use that sample. I'll show that photo. Yes, they will use the sample over here in the test tube. So they will put some test tube material. So all this quantum material they will put, and this will act like qubit, like a collective qubit, ensemble qubits. So each and every quantum computation will have different approach. So this is based upon nuclear magnetic resonance. So I will share this link to you. Yes, yes, same technology we can use for quantum computing also. Very good book. I will suggest Nielsen Chung, Quantum Computing, Nielsen Chung. So this is like Bible for the topmost university. So whenever they study quantum, they will refer this book. like de facto. I will share this Amazon link for you. You can find cheaper copy. I bought this book before 6 years. Very good book, and it will be little difficult for you for beginners. Thomas Wang, Quantum Computing. You can check this book, very easy. This book is open source, so you can download this book and you can take printout. The easiest book. I don't recommend PDF pirated version. So, but this one is open source. So whenever if you are in open forum, we should not promote the pirated book, e-copy. Okay. So if you have this book, okay, these two professors, they worked around 25 years and 30 years. They did research. Out of that research, they prepared this book. Which PDF? I shared the PDF of this book. I shared PDF of this book, but this is proprietary. We need to purchase. So that is why I'm telling. So the cost is only 900 rupees, less than 900. So what is the information? These two professors involved 30 years of research. Okay, they documented, they tried to abbreviate it in a comprehensive way. They created this book. For the research effort, we need to respect. We need to pay something. So paying 1,000 rupees is nothing when compared to 30 years of research experience. So this is my point. So even though if you are able to download PDF, always go for printed version. Okay, investing 1,000 rupees is nothing for us. Okay, so go by paper book. So you won't get tired. You can flip pages here and there multiple times, right? It will be easy for you, especially for quantum. So don't go by PDF. For slides, that is okay. For book, very difficult for you. You will get tired because lot of mathematics involved, lot of diagram is there, lot of time you need to stare that information, right? So plenty of books is there, but you need to select. So I recommend only 2 books. This is more than enough. And one more book is very interesting, quantum books. If you Google, lot of books will come, but selecting the right book will take so much of time. Never mind, I will put all these link in your slide. If I am sharing some slide, I have 10 to 15 good quantum books. I'll share that link with you. QML book, yes, very good question. QML book written by Microsoft people. I'll mention that book. This book. I will share this Springer link. You can go and check. This book is very good. Okay, Aman. So any other doubts, any other question? I can read from chat. Yes, PQC algorithms are good candidates. Yes. Difference between machine learning and quantum machine learning is almost same, but here you are using quantum computation for solving that purpose. Okay. Whatever you are doing machine learning, you are about to do in quantum also, but the way you are doing that differs. Software I can recommend Overleaf. So this is online latex editor. We can create account over here, and we can create latex document to create all this formula. Okay, any other doubts? That is what I told, right? First, try to complete 2 courses from IBM. Okay, course 1, course 2, algorithm, then go for quantum machine learning. Definitely, you will have some idea. So shifting classical machine learning to quantum, you need to understand how quantum works. Slowly, you will know by yourself. So it is very difficult question to answer because multiple approaches there, multiple ways are there to map. It will take much more time. Not every classical machine learning problem is suitable for quantum. Only specific problems are available. So it entirely depends upon the complexity. So Monday class we will discuss. So what is the complexity of an algorithm and how to select? How to select. Financial fraud detection, yes, suitable. If you Google uh, um, quantum finance in Quiskit, you will have some idea. Fraud detection you can do. Okay. I will share this link in chat box. That is why if you go for Quiskit, you will have a lot of resources. So try to explore all these tutorials. So all these problems are related to finance. Okay. Fraud detection, you can use quantum Quiskit. Tutorial is there. Then what is the one more question? Natural language. Which one you are asking? How many qubits? Quiskit. Quiskit, you can work until 133 qubits. PML, this question is PML 133 they are providing. So more than 133, you need to request them. You need to pay them per minute. If you are willing to pay 9,000, they are ready to increase number of qubits. Okay, any more questions? Natural language processing. Nobody can NLP problems we can solve. Natural language processing is very complex to do. Definitely quantum will help you. Okay. If you Google quantum NLP, lot of results will come, especially in Quizzkit. Neural networks are there, quantum natural language processing is there, right? So what are the complexity available in classical? Definitely you can consider in quantum version. Right, I will share this YouTube link to you. I already told about Quizzkit YouTube channel. So in your lifetime, you never able to complete all these topics. That much of resources are there. Okay, I will recommend one-stop solution. So whatever you have doubt, whatever the problem you have, you go to this YouTube channel. You go to this YouTube channel. You have plenty of playlist. You have plenty of playlist. Okay, all the quantum summer school, whatever they discussed, right? Whatever the guest lecture they conducted, okay, coding part, each and everything is there. Each and everything is there. In your lifetime, you cannot see all this video if you continuously watch for 200 years also. That much of videos are there. So this one link is more than enough for you. I hope so. How to stop? Here I can stop. Thank you all.
Thank you, sir. Thank you very much. I think the participants might be overwhelmed with the number of tools that you have introduced to them. Participants, kindly, all of them are very, very important. Even if you want to do something, you will have to do the programming and implement that somewhere where everything that has been discussing will be useful to you. So kindly pay very close attention to all these lectures and kindly also go back to this YouTube video once more and do that hands-on if you missed it somewhere in between. So thank you, sir. Thank you very much. We have also been listening to some of the parts, and it's very insightful, and many of the things we clear it up. So thank you for myself also. Uh, and participants, thank you to be here. And sir, we'll once again meet tomorrow at
Yes, sir.
3
Thank you.
o'clock,
Thank you.
right?
Definitely, sir. Thank you.
Thank you, sir. So thank you very much, sir. We'll meet tomorrow once again. Students, participants will have to discuss about the quiz that we are going to have. Please note that the quiz will open tomorrow morning about 8 o'clock, but the time will come. We'll see on the canvas. So from tomorrow till Monday, the quiz will be open. We'll probably open quiz 1 also. So whoever has missed